Hello. Here to talk to you about Clojure, show you the way, the journey to the promised land. If you feel inclined to shout at me over my opinions, or you'd just like to talk about them, there's a Twitter handle for you. A while ago, I was here to talk to you about Redux and React, and I was absolutely convinced that that was the promised land. Hence the angry cat. Prior to doing what I do now, working at Simply Financial Services, I started studying at TICS, and I was quite arrogant about what constituted software development. I thought that JavaScript was something that neckbeards wrote. I thought that web development was not for me. But not long after that, I graduated from university and got a job as a web developer. It was really exciting times. It was sort of before Angular came along. It was before NPM was a thing, and it was before Node was a thing. And in order to create classes, essentially, we used to do these things called ifs, which are immediately invoked function expressions. And using that and the parameters that you pass to them, you can ensure that nobody can modify or look at things that they shouldn't be able to before you want them to. So this is a class as an IFI. I send in a first name and a surname. I add a space in between to make it a proper name, and then I return it whenever I want to. This is also a pure function, and this is how you deal with privacy in JavaScript. Cool. So on the subject and importance of privacy, we have a base class written in C. And it is so important that the privacy of your properties is transitive to anybody who inherits from you. And in fact, should you try and return things you shouldn't be able to, your code will not compile. So in this example, I have created another pure function that gives me a full name when I provided an array of characters in my name. And I thought that I could be really smart and trick it into saying something else when I called .fullName. Instead, I had to change the references to what I sent in order to make it say something else. So this really highlights how important references are and why pure functions are super important. So any pure function can be translated to a lambda. Here is a lambda where I just add x and y with a space in between to give me a full name. And in this example, we'll be looking at Redux and the Redux flow. I would argue, and I believe most people would, that any application worth its salt keeps state far, far away from the stuff that changes the state in your application and from the view and the view model and the display. Hence, in our store, we have these actions. And from those actions, we send to our consumers something called an action creator. Should I choose to add a to-do to my list of to-dos, I will call the action creator and I will call the store's dispatch method to have it mutate the store and add my to-do where I need it. So along with the store comes a function from React Redux called connect. And this does some magic to send the updates you make to your store to your front end so that it can display that. And in addition to that, you need to ensure that your data structures are unique every time you change them so that it knows to re-render. So from the store, we can pull these pieces of state, and each piece of state is unique to a reducer, and we wrap the pulled state in a function and send it to our components as props. This is how we abstract how we display things and how we modify them. This is Clojure's benevolent dictator, Rich Hickey. It took him about 2 years and 8 months to write Clojure. It is a dialect of Lisp. It is a dynamic language, and it is highly opinionated and fun to work in. So Clojure is a dialect of Lisp and shares with Lisp the code as a philosophy and a powerful macro system, which means that in my REPL, I can modify lists and reduce over them, change properties on those lists as I please. I know it'll work, and it's just a great time. Once again, dynamic language. So over here, we look at Clojure expressions. You start off your expression by wrapping it in parens. Do not have fear of parens. Don't be a fop. You have a symbol at the beginning, a number, and another number, and those are like your parameters, and you can chain them together, and these functions are very high arity, so you can pass as many parameters to them as you like. Since we're going to be looking at Clojure in a little bit, we should know more about Clojure's data structures and how to manipulate them. The first data structure here is a list. You denote the list by wrapping your data in brackets and then adding a semicolon at the front. A vector is the same thing, but it's got square brackets. A set is unique, but it's got the curly braces. And then a map is very similar to a dictionary in the sense that you can index into it and modify things. And they're great for Clojure. So next thing is def and define function. So I can declare something, and then I can do something with it by defining a function. And the functions are unique. And we also have symbols, we have maps, we have nulls, we have trues and falses, we have namespaced keywords, which can also be applied to symbols. And then we can work with collections. So in the first example, I'm iterating over the collection and adding 1 to each element in the collection. Next, I reduce over that, and 1, 2, 3, 4 gives me 10. This works with sets and vectors too, but it's worth noting that the vectors or sets become a list. So what that means is that if you add something to the vector, it goes at the front, because it's easy to add things to the front of a list. If you add something to a vector, it goes at the end, because you just iterate over it and you pop it in the end. Once again, reducing over 1, 2, 3, and 4 to get 10. So I can concatenate and conjoin collections. The first one is a vector. So when I concat onto the vector, the element added is added to the front of the vector. Then one of the great things about Clojure is the thread first macro, conventionally known in languages like JavaScript with the use of ramda and lodash as a pipe. So you pipe something from the left, comes out the right, completely changed. I've done that with concat, and I've got a long list of 10 items. I map over them, I add one, I filter for the even ones, and then I return that. When you use functions in Clojure, the last thing that you return is what is given to the next function. So I've said hello world, I've wrapped that in a function, I've printed hello world, and because I've printed it, I get a nil back, because that's IO, and there's nothing I can do with that. So some things to know: all of the data structures in Clojure are immutable. It is a hosted, dynamic, general-purpose language, and you cannot mutate data. It's very similar to Ramda, where if you add something to a map, the stuff that you add is shared, and everything else is shared with the other people. So how to explain? It's just memory efficient because you don't need to repeat references for all of your consumers. Compared to JavaScript, for me, it erases many of the common woes like inconsistent types, true and false inconsistency, unintended type conversions, shallow versus deep cloning. So in the Redux example earlier, we had to spread our to-dos in order to create a new list of to-dos so that our front end would know that something in that list had changed. This is not an issue with Clojure because of how it modifies lists and vectors. There are huge operator precedence tables in JavaScript, and there's inconsistent equality checking. So for me, one of the biggest highlights about Clojure and one of the best things is the REPL. With the REPL, you can pipe stuff together, map them, get an immediate output, debug that stuff, pop it into a file, make it part of a test for next time. You can stream it to the front end. You can stream it wherever you want. It's really great. So Clojure makes life simpler because it just gets out of your way. It allows you to be hyper-productive. It allows you to just do things that make developers sing with joy. So on the subject of functional programming, I want to take a moment to talk about event sourcing. If you're familiar with PubSub, then you'll be familiar with event sourcing. This is a model that we use at work. All of our stuff is hosted on the cloud, which means that all the data is eventually consistent, but it doesn't, like if something breaks, it'll keep retrying until we can consume that event or it dies for all intents and purposes. It's just a nice way to deal with data. You don't have to worry about stuff going missing. If you, for example, have a store and you want to move stock between different parts of the store, you just say, like, I bought 10 sheep. I want to send 10 sheep to the showroom. Someone else bought 10 sheep, which means that I need to credit their account with like X amount of sheep times 10, and I need to debit my account with the converse. It's just a great way of dealing with data. So for example, the balance of an account can be projected by summating all credit and debit transactions made by the account. So events should be used to track the movement of stock in a store. I'm using event sourcing as well to write an application that records electricity. So you take the reading, you minus the next highest reading, and you multiply that by the cost per kilowatt hour to get an idea of what you spend on electricity every month. Come on, buddy. So there was more. I'm just going to show you guys the REPL now that I was hopping on about. Not sure what's happening here. Okay. Make it bigger. I can't. Make the font bigger. Okay. There you go. Happy days. So I require the file system from JavaScript in order to read my events from my event log.
Is that just the normal NPM packet, the normal Node API?
No. It's ClojureScript, and then it builds to Node.
Oh,
So
okay.
I don't know if that's what you meant.
No, well, the FS library that you're using.
Yeah.
The built-in one.
Yeah.
It's Node. Okay.
So I'm just working with that with callbacks. I just have a long list of events that I read in using Clojure's CLJS reader, which reads Eden. It's like a type-safe data at rest data structure. For example, I'll know when dates are dates and when other things are other things. Okay, gonna read the event log. Oh, come on. Thank you.
So would you say a good definition of the REPL is just Clojure's kind of a command line utility that allows you to evaluate Clojure code and expressions in real time?
Yes, it stands for the read, evaluate, print loop.
Okay.
So you read some code and data from the REPL,
Right.
and you write it out, and you modify it however you like.
Right. So you're presumably executing each statement or each line there right now in the REPL, right? Is that
Yes, when I push the right buttons.
Okay, if you push the right buttons, right. Okay.
But I think it also has some cool shit where, like, if you can actually instantiate the REPL in a live program.
Right.
With Lanigan.
Right.
Yeah.
Yeah. So Lanigan's pretty cool. It allows you to manage your dependencies. So I'm using debs.eden here, which is just not cooperating with me. And it will just download things as you need them so that you can just write code.
That's why I've had tremendous arguments about Lanigan and CLJS as a standard depth management tool. Right, John?
Okay. So here I've written an event to the event store where I've created an account. Once I've written the event, I can do anything with that data. So this would be an opportune moment to sort of stream that data to a front end, to consume it, just to do whatever you want with it. There's like just wads of data coming through. Onto each event at the top here, I associate a timestamp over there, which allows me to sort them and order them so that I can find usage since the last time that X individual recorded their electricity. I think that's me. Job done.